Hey everybody, welcome to the 27 Virtual Podcast. My name is Bill Grismore. I'm here with the studious Andrew Grismore. Thanks for joining us today, Andrew.
No problem. Pleasure to be here. I'm excited about today's topic, actually.
So, on this podcast, what we like to do is share with our listeners all the tips, tricks, and everything we've learned in the field, and some basic concepts to help you better understand some of the different VMware technologies. In this case, we're talking about NSX. So on today's topic, Andrew, I have this thing called a transport zone, which is apparently it's something important with this thing called NSXT.
It is incredibly important. It's been important for a long time, and I think that it's one of the things that's net new to NSX when you start getting into it if you're just used to the vSphere world. And there's usually a lot of questions and misconceptions around it. So hopefully we can clear some of those up today.
So what is a transport zone? Does it transport me to some other time and place? What is it doing to me exactly? Or what is it doing for us, I should say?
So in its essence, the transport zone defines the scope of our virtualized networks. That's about as simple as you can put it. So it defines where our virtualized networks are going to be. In the physical world, when you denote where a VLAN is going to live and the ports where it's going to be active on that physical piece of hardware, that's as simple as it gets. You have that VLAN in that place. Well, when you're talking about virtualized networks, it's a little bit different because we're not relying on the physical network and ports to define where our networks are going to live. So we have to have something that's going to do that, and that's what the transport zone is for.
So on a physical switch, I'm basically trunking VLANs. And I can trunk VLANs across multiple ports. I can do individual ports like an access port, or I can trunk VLANs across a range of ports or an entire switch or multiple switches. Maybe spanning tree gets involved. So how does that kind of compare then into, how do I make that comparison then into the vSphere world?
Yeah, I mean, it's really similar. So just like that, if you have a certain span of your VLAN in the physical network, that's where that network lives. Same is true for the transport zone, except for that because we're talking about NSX and because we've talked about one of the capabilities of why NSX in a previous podcast. With NSX, you get the ability to span your layer 2 networks over layer 3 boundaries. And where in the physical network, your layer 2 may end and hit a layer 3 boundary so that you can have possible pods within your data center or go from data center to data center. That layer 2 may not go all the way across, but with NSX, we can make it span via the Geneve tunneling. So in order to preserve the fact that we can have the same network exist across these multiple areas, we have to have somewhere to drop that network. And we're going to put that network in the transport zone so that when a VM plugs into a network, it can utilize that network across the entirety of where we want it to exist. The main difference is from a physical perspective, the physical network configuration defines where the network lives. In our NSX world, the administrator of NSX decides where the network lives by creating the transport zone and instantiating that transport zone and the NSX virtual switches that go along with it. On the hosts where we actually prep them. So when you go through the process in NSX of prepping your ESXi host, and you say, I want it to have this NVDS and this transport zone, you're essentially saying when I create a segment on one of these hosts, it's going to, or create a segment, it's going to live on one of these hosts where I have that transport zone, or many of the hosts where I have that transport zone.
Okay, so let me make sure I understand. So I'm going to go in. Now, if I don't have, if I didn't have NSX and I'm just in vSphere, I would go into vSphere, I would create a port group, and the port group would live either in a standard switch or a virtual distributed switch. So how does that work in NSXT? How is it different?
Yeah, so without NSX, you have the standard, you have the distributed port groups, and when you create the port group and you assign the VLAN to be associated with it, you need to make sure it matches up. And when you create a port group on a standard switch, you know that that port group exists on that one host where that standard switch lives. So when you create it, it exists there. If you were to create that same port group on a distributed switch, well, now the span of where that port group lives is going to go across the multiple hosts where the distributed switch exists. And then to step it up one more level, because NSX doesn't rely on that physical networking for the segments that our VMs are plugged into in the overlay. Now, if we create a transport zone that spans across multiple VDSs, we could actually create the segment for our VMs to use in that transport zone, and it will get pushed to multiple VDSs or NSX enabled distributed switches. So you can think about how your networks actually span in the virtual world, or your port groups span via one host for each standard switch, multiple hosts for each distributed switch, and then multiple distributed switches possibly for a single transport zone. And that can help you define the scope.
Okay, so if I have two data centers and I have a virtual distributed switch in data center A, and I got a virtual distributed switch in data center B, what you're basically saying is the transport zone can encompass both of those VDSs. So now instead of creating two port groups, one in one VDS and one in the other, I now just create my NSXT segment in the transport zone, and then it basically drops it across the entire environment. Is that right?
Exactly.
So how does that help me then?
So that allows you to create your overlay segments and have consistent networking in both of those locations. So as far as your VMs are concerned, they're plugging into the same segment, whether they're in virtual distributed switch A or virtual distributed switch B. The VM can't tell the difference if you were to migrate it from one data center to another, from one VDS to another. It has no idea that that's actually happening in the background. As far as it's concerned, it's plugging into the same construct, which is our NSXT overlay segment. So your VMs can live wherever that network spans, but and plug into the exact same layer 2 that it was using before.
Wow, so that sounds pretty powerful. So now I just build network, I build, well, not networks, I build NSXT segments, if I use the right terminology. And I put the segment in the transport zone, and then it just puts it wherever I've defined wherever that transport zone lives based on what hosts or clusters were prepped for that transport zone.
Exactly. And I would say a big key if you're used to NSXV and you're going to NSXT is that there are actually now two kinds of transport zones. The one that we've been talking about for all these networking examples is the overlay transport zone, which allows you to extend those layer 2s wherever you need them. But there's also another transport zone, which is very important as well, and it's the VLAN transport zone. And in the VLAN transport zone, you're going to be creating port groups very similar to how you created port groups without NSX at all. So you're creating VLAN-backed port groups or segments in your VLAN transport zones. And some examples of where we would use the VLAN transport zone are for the north-south transit networks in our our edges for our gateways to use for north-south traffic, as well as you can just create them on your ESXi hosts if you're looking to do a pure security NSX setup. So for security, you have to have your VMs, VNICs plugging into a segment in NSX. And if you don't want to change their physical networking, if you want to continue to use VLANs, you can create a VLAN segment in a VLAN transport zone and use it just like you would use your original port groups without NSX. So you can create overlay and VLAN transport zones. Both of them define the scope of where your network is going to live. Just be aware of if you're creating an overlay or a VLAN.
Now, this VLAN transport zone didn't exist in NSXV, is that right?
Correct. It's a brand new idea construct for NSXT.
So if I want to do security on a VM in NSXT, and I don't care about overlay stretching the layer 2 network, you're telling me that I still have to create a segment, but this time the segment is going to be in the VLAN transport zone. Is that correct?
I am indeed. And then the main misconception that I want to clear up here is that a VLAN transport zone, or any transport zone for that matter, is not a security boundary. If you create VLAN transport zone A and VLAN transport zone B, and those two and the VLAN segments that you create can route to each other in your physical network, there's nothing that's going to be in place in the NSX world that has to do with your transport zones that are going to stop those two transport zones and the VMs that live in them from communicating with each other. It is not a security boundary. You want to use your groups and tags to define how VMs communicate. You can't use the transport zone in the first place, and there's nothing that it does to limit communication.
Very interesting. So that's awesome. So I think that pretty much covers the transport zone concept at this point. So Andrew, thank you very much for joining us today and your information and insight on transport zones.
My pleasure. If you have any questions about them, feel free to hit us up at 27virtual.com.
Great, thank you.